Hi, my name is Samuel Leach, and this is my presentation on my experience as a fossil hydro operations co-op as a part of the FHO engineering co-op program at Duke Energy. Before getting started, I want to quickly note that due to Duke Energy's privacy policy, the name of the plant I worked at and photos specific to the plant have been omitted from this presentation. While some photos have been replaced with stock images from the internet, the information in this presentation is very representative of my co-op experience. During this co-op session, the division I worked with was the Duke Energy Plant Technical Team. My manager was Sherry Young and my mentor was George Galley. I can't say enough good things about George and Sherry. They both treated me with respect and helped me learn a ton of things at the plant. As for my co-op session, this was my third one overall. During my third rotation, I got to work on a number of different projects that had an impact on the company. The first project I worked on was the 5-year inventory static list. This project consisted of devising a system at the plant that identified material that had been in storage for 5 years. This material was then evaluated and either kept or thrown away. This project was very important to the plant because the plant is charged an extra tax for the amount of inventory they have that is over 5 years old. The next project I worked on was the SCR ammonia skid repair. The ammonia skid at the plant stopped working during my first week of the rotation, so it was my job to troubleshoot the issue, identify the problem, and develop a solution to fix the skid. The next project I worked on was the Cranes and Hoists Update merger. This project consisted of identifying every crane and hoist in the plant and verifying that the cranes had been properly inspected. The final and main project I worked on was the Sims Building air compressor line redesign. This project is the main focus of my presentation. Before getting into the Sims line redesign, I want to talk a little bit about the SCR ammonia skid project. The image on the screen is a hand-drawn diagram with numbered points that I made at the plant and used to help repair the skid. I identified what was wrong with the skid by using a borescope to look inside the piping at different points. A borescope is a small camera that is attached to the end of a long line that can be used to examine the inside pipes. When looking into the skid, I immediately noticed that there was a complete blockage of the pipe at point 3. In addition, it was also evident that there were high levels of blockage in valves 5, 7, and 10. The blockage at each point was actually bottom ash that was blown into the SCR and reacted with the ammonia. In order to fix this problem, the skid was deconstructed at the necessary locations and hydroblasted to completely clear any ash. I also installed a new flange as shown in the drawing that allowed for quick assembly and disassembly of the skid to clean out in the future. The pictures on this slide are images from the borescope that I used to look at the SCR ammonia skid. As you can tell from both pictures, there were complete blockages at a number of valves, and this had to be hydroblasted because it was too dense to just clean out using air. The main focus of this presentation will be on the Sims Building Airline project. The main objective of this project was to safely give the Sims building air. SIMS stands for Continuous Emission Monitoring System. The building needs a steady supply of air for its measuring devices to work. The original compressors to the building were very outdated and no longer delivering adequate air, hence the need for this project. To complete this project, I had to develop a plan for decommissioning the old compressors, plan and map out a new airline, and plan for an install. Personally, my objective was to plan and create a project by myself. In my previous rotations, I got to work hand in hand with other engineers, but I was never the lead on a project. So for this project, I was the lead. I got to see if the project is viable, work with a budget, work with plant personnel, and design the line. I also got to learn more about the SIMS systems. My previous 2 rotations were spent in boilers, so I didn't get to work with a lot of the back end stuff like the SIMS and the FGD and the stack. The first piece of the scope was to communicate if the project was even viable. The project would only be viable if new compressors gave the Sims building adequate air and it was profitable for Duke Energy. If the project was not profitable, then there would be no reason to continue with the project to the next pieces of scope. The next piece we needed to do was to gather info on the new and old compressors. There were new compressors installed at the water treatment plant that are extremely powerful and brand new. We thought that it'd be a great idea to run a line from these compressors to the Sims building as long as they could adequately sustain this level of air that we needed. We also needed to get info on the old compressors because we needed to see what the difference was between the old air that we were getting to the Sims building and the new air. The next piece of the scope we needed to do was to create a strategy for installing the new line. Installing a line can be expensive, so we needed to design the most cost-effective way to install a line from these new compressors to the Sims building. All of this includes lining up costs and cost savings, so we can see how much money we're putting into the project and how much money the project would save for us. Lastly, if all this goes well, the plan was to install. As mentioned earlier, there were 2 new compressors that were installed at the wastewater treatment plant. After conducting research, I determined that these powerful compressors would be strong enough to adequately supply the Sims building air along with the wastewater treatment plant. This plan was very profitable because the compressors were already operating for the wastewater treatment plant. The old compressors that were supplying the Sims building air cost about $4 per hour to operate. If you do the math, this runs out to $2,976 per month and $35,712 per year. And this was only for each compressor. There were 2 total compressors, so the total cost per year was around $70,000 just to operate with those old compressors, and they weren't even supplying adequate air. It was also $3,000 per year per service for the compressors, and that was per compressor as well. So it was $6,000 per year to service both compressors. These new compressors eliminated both of the costs because they were already running, already being serviced, and already supplying air to the wastewater treatment plant, so it was no extra cost for them to supply the Sims building with air. One of the challenges of this project was communication. I had to communicate information for this project to my mentor, different engineers, plant managers, shop personnel, and also the Sims building operators. All these people were very essential for this project, so delivering adequate information to all of them at a timely manner could be challenging at times. The next challenge was line design. The line that we were trying to make between the new compressors and the Sims building was somewhat expensive, so we had to figure out some cost-cutting ways to design this line so it could be installed in a timely manner and also at a good budget. Timeline was also difficult because I was only at the plant for 3 months in the summer. That was the length of my rotation period. So I had to develop all of this stuff in those 3 months and try to get the project as done as possible before turning it over to my mentor. The final challenge was the receiving tank. The receiving tank was actually a big problem with this project because the new air compressors were adequate for supplying air to both the wastewater treatment plant and the Sims building, but the receiving tank attached to the air compressors was not. So we had to develop a new strategy for tying in the actual old receiving tank into the new compressors so that there was enough receiving tank capacity to adequately deliver air to both of these buildings, even when both buildings needed air. That's the point of the receiving tank. The receiving tank is basically a surplus of air to use in case the compressor is being pushed very hard. This project resulted in being very successful for Duke Energy, the plant, and myself. After determining cost savings and completing the calculations on the new air compressors, it was determined that the project would save Duke Energy thousands of dollars each year, and that the new compressors were strong enough to give the Sims building a constant supply of air. The design for the line was successfully created and planned for the project. The image on the slide shows a map of the planned line. The red lines represent a completely new dugout line, while the black lines represent previously made lines or trenches. Using previously dug lines and trenches was beneficial because it reduced the cost for the line layout. In the layout, a new line was made from the new compressors that took advantage of previously made trenches between the wastewater building and another building. Using this trench allowed us to save on line digging costs. This line was then tied into the red line, which is a completely new line that feeds the air to the Sims building inside the stack. This new line also tied into the old compressor line that is attached to the old receiving tank. This allowed for the old receiving tank to be used as well as the new receiving tank, giving the whole air system adequate receiving tank capacity for when the wastewater treatment plant and the Sims building need maximum air at the same time. Due to time constraints with my rotation, the line was not able to be installed by the end of my session, but it is planned to be installed before the end of 2020. My work at Duke Energy over the summer helped impact the company in a number of ways. One of the main impacts was cost savings. My work with the Sims airline project will save the company over $50,000 per year, while the cost of the project itself was under $50,000. My work on the SCR ammonia skid helped get the SCR up and running as quickly as possible without a full outage, saving the company money that would have been lost in an extended outage. The 5-year static inventory project also helped save the company thousands of dollars in the form of taxes that would have had been paid if the inventory stayed in Duke Energy's warehouse after 5 years. I also helped positively impact the company by creating efficiency improvements in the plant. The new air compressors at the Sims building are much more efficient than the old compressors, meaning there is more air supplied to the Sims building per dollar compared to the old compressors. The Cranes and Hoists project helped improve efficiency because now there is an infrastructure for checking the inspections of each crane in the plant and one central location that identifies each crane and hoists and their information. The Crane and Hoists project also helped the company comply with all OSHA standards and ensure that all cranes and hoists could be safely operated. Lastly, the 5-year static inventory project positively impacted the company because now the system I created for tracking can be used year after year, saving the company precious time and man hours when going through the 5-year static inventory list. During this co-op rotation, I gained lots of insights into Duke Energy I would not have previously had unless I worked for the company. One of the big things that I realized is that the company is a big company, but it has a family environment. So what that means is Duke Energy is undoubtedly a big company, but at each plant there is a small core of people who are very tight-knit and look after each other. I really appreciate that, and that helped me a lot in this co-op rotation. You can tell in my picture here that it is myself and 2 of my coworkers all in Red Sox jerseys, and we were celebrating the Red Sox win a game. And that was only after 1 month working there, and I was already close enough to have a good relationship with them as well as many other coworkers in the plant, which I'm very thankful for. I also learned that safety is a very paramount thing at the company. Safety is an utmost importance at Duke Energy because they want to make sure everyone is safe and no one gets hurt. This is extremely, extremely important to not only comply with OSHA standards, but just as a moral code that you always want to have all your workers go home safely. I also learned that there are a variety of jobs within Duke Energy. Even if you don't want to be an engineer, there are plenty of jobs in purchasing, secretaries, different financial people, things like that. But there's also a bunch of different engineering jobs. You can work in the FGD, you can work in the boiler, you can work in the coal receiving system. There are so many jobs at Duke Energy, so there's a lot of chance to do a lot of different things within the company. Lastly, I learned there is also a very high opportunity for impact. As a co-op, I got to make actual change in the plant. I got to help save the company lots of money, and I got to be very hands-on and learn a lot of things that I never would have learned unless I did this co-op. So there's a very high opportunity for impact for co-ops and full-time people alike. In addition to gaining lots of insight about Duke Energy as a company, I also gained insight into the energy industry itself. The first thing I learned is that there are a lot of career path options in Duke Energy, but also within the entire industry. For example, I worked with vendors and Duke Energy engineers alike that worked on the FGD side of the plant, ensuring that harmful gases such as NOx and SOx don't enter the atmosphere. But I also worked with people who were in charge of coal handling, people who had direct communication with coal mines and made sure that there was an adequate amount of coal at the plant at the right time that allowed for the plant to be operating at full potential. The next thing I learned is that communication is key. Communication is very important within the plants, but also within the entire industry because you have to know how to talk to different types of people. When working as an engineer, specifically in the energy industry, you are going to work with people who have been boiler workers their whole life, but you're also going to work with business people who aren't necessarily engineers. It is very important to know how to talk to both of these types of people because they are both essential and they are both very, very important and they deserve your respect. The next thing I learned is that you have to be multidimensional. What I mean by that is you have to be willing to do different things. Some days require you being on a computer the entire day and running calculations and crunching numbers and developing budgets. But other days, you have to be able to get out into the field and be willing to get dirty and be hands-on. The picture on this image shows me being hands-on with one of my other co-op friends. We did a boiler crawl one day during an outage and we got covered head to toe with ash and coal and a bunch of different stuff. But you have to be able to do that and also work on a computer at the same time and just kind of show different sides of yourself and your abilities. The last thing I learned is that you have to have the ability to problem solve. This is important across the whole industry in general because problem solving is pretty much what you are always doing as an engineer. You are always going to be presented a problem and you're going to have to either develop a solution or design to solve that problem. So problem solving is very important. And while I knew that was important, working at Duke Energy and working in the energy industry just showed me how important problem solving skills are and how you have to be creative to solve things. For example, I had a problem solved with the receiving tank for the Sims air compressor project because we did not have enough receiving tank capacity with the wastewater treatment plant. So I had to be creative and use my problem solving skills to tie in the old compressor so we could have two different receiving tanks at the old compressors and the new compressors so we would have enough receiving air capacity. I experienced lots of personal growth while working for Duke Energy in this rotation. The first thing I learned was how to be professionally independent. This was my first time ever working on a project and heading a project by itself. So I had to learn how to be independent and make decisions that are not necessarily easy decisions. I had to learn how to evaluate different people and how to assign an importance value to what matters for different parts of the project. So learning how to be professionally independent was very important for me and something that I can use for sure going forward. I also learned how to communicate with different professions. It was very important for this project that I worked with engineers, boiler people, and business people. So I got to communicate with different types of people, and my communication skills definitely grew throughout this co-op rotation, and it is also something I can take into my career path going forward. I also confirmed my passion for the energy industry. I have always been interested in the energy industry because I grew up very close to a nuclear plant. But working in a coal plant and working just with a company that works with energy really confirmed that passion and is definitely an industry that I want to go into for my career. I love working with turbines and with FGD systems and with boilers, so that is definitely something I want to get into. Finally, this also confirmed my career path. My career path, I have always been very interested in the energy industry, but I did not know what specific area of the industry I wanted to get involved in. I now know that I definitely want to get involved in the plant producing power side, whether that be coal, natural gas, or anything else. But I'm very interested in the plants and like being hands-on with all the equipment in the plant. So that is definitely something that I want to get into and something that was definitely confirmed during this rotation. I appreciated Duke Energy before working on this co-op rotation, but I appreciate them even more now. They treated me with nothing but respect, and I have nothing but good things to say about my co-op experience.